Hi once again. We just examined inverting amplifier. Now we will be examining positive amplifier. So let me write a positive amplifier. So we are talking about op-amp circuits that we use in practice. So this is one of them. So our aim here is this circuit is given. So we've got to check whether this circuit does positive amplifying or not. In order to do that, I do not need to calculate all the elements current and voltages. All I do need to calculate is this V out in terms of VE. That's input. That's that voltage. So if I calculate this, then I can then say this circuit input transferred to this output. So what this circuit does, inverts this input to the output. So if I find an equation like that, so that means I can interpret whether it does positive amplifying or not. So the definition relation of our ideal operation amplifier is Vp minus Vn is almost 0, Ip minus In, Ip equal In is almost 0. So this current is almost 0 and that voltage is almost 0. So what is this voltage? So you're going to consider those two as node voltages. So this is the Vp minus Vn. This node voltage minus this node voltage gives this terminals voltage, which is equal to 0. Okay, as we have done it previously, we are going to write Kirchhoff current law equations for this equation for this node, just one node, one equation, of course. So what is this equation? We need to choose the element current references in order to write a Kirchhoff current law equation. So I have chosen these references like that. If you choose it the other way around, the results do not change. So you could do it your own. So come to that now. So this current here towards the node, that's why it is minus IRS. And this current towards the node, that's why, therefore it is minus RF. So this current here, IN, is equal to 0, so I didn't write it here. Addition of these currents gives you 0. Although there should have been three terms here, just two is seen at the moment. The third one is equal to 0, therefore it is not seen in the equation. This equation is not the one that I am looking for, because I am looking for an equation like that. So what does this mean? I am going to transfer these variables to these variables. How we could do that? We could see now, this is ground, isn't it? Connected to ground. So that means that node voltage is 0. What about this node voltage? So if I use the definition relation of this operational amplifier, it says IP current is equal to 0. Let me show it in different colors. So IP current is equal to 0. So if I use that, that means that current is equal to 0. If that current is equal to 0, that means this current is the same as this resistor current. So the resistor voltage becomes current is 0, R times 0 gives you voltage that is equal to 0. So that voltage is 0. If that voltage is 0, then this node voltage is going to be VI. The difference between those two nodes is 0, that means VI volt comes to that node. So we found this node voltage is equal to input voltage. So you can easily write this current in terms of this. So let me write it. So minus this current here, 0 node voltage minus VI node voltage over RS. So this is that one. And what about this? So this node voltage is 0, that node voltage is VI. So V out minus VI over RF is equal to 0. From that, if we keep it as it is, so VI minus RS, if we put this on the right hand side, it's going to be V out over RF plus minus VI over RF. So I moved this to the right hand side, so this negative became positive. So and then I wrote this in this form. So from that, what I get, V0 over RF is equal 1 over RS plus 1 over RF in parentheses VI. So I made a mistake, did I? This is not VF, of course, this is RF. Isn't it? R0 over RF. So it's going to be RF. So then V0 over RF is RS plus RF over RS RF VI. So that gives you V0 is equal RS RF over this RF's gone, so RS VI. Now this is what we are looking for. We found that. So interpretation of this result tells me the sign here is positive. So when I said positive amplifier, so we have done this. And RS plus RF over RS is bigger than 1. That is bigger than 1. Why is that? This is smaller than this, isn't it? So bigger than 1. So that means this is bigger than 1 means the output has been increased by this coefficient while this VI is the input. So that means this part amplifier is the interpretation of this. Then I can say that this is a positive amplifier, this circuit. So this is our aim. So we can finish this video as well.